Gas keeps us warm in winter, allows us to travel, and feeds the stove we use to cook. In Western countries, gas is an essential resource for many aspects of life as we know it. But how much do we really know about how it gets to our homes? Welcome to The Journey of Gas, a podcast by Flavia Bazzano and Marianna Betti about the human element of energy production and distribution. Welcome to the third episode of The Journey of Gas. I am your host, Flavia Bazzano, and we are with Marianna Betti as usual. In our previous episode, we talked about the social implication associated with the dynamics of extraction. We have seen how the process of extraction can be more or less painless for local communities. After the extraction, the gas must be prepared to be transported on different carriers, to be fed into the pipelines of the grid and reach its final destinations. First of all, why is the transformation of gas necessary?
Good morning, Flavia. The transformation of natural gas from its gaseous state to a liquid state is known as natural gas liquefaction, and the liquefied natural gas is known as LNG. This process is necessary to reduce the volume, to facilitate transportation and storage, and it's basically necessary to turn natural gas into liquid for safety and efficiency. Natural gas is often extracted and stored in pressurized or low temperature forms, depending on the conditions under which it is found underground. Processing gas may involve pressure regulation, removal of impurities, or liquefaction to reduce the volume, making the transportation of gas safer and more efficient. In our journey, we will deal more with liquefaction than compression. And liquefaction, in fact, significantly reduces the volume of natural gas. When the gas is in the liquid state, in fact, it takes up to 600 times less space than when it is in its gaseous state. And this makes it more practical and convenient to transport over long distances, especially through sea routes, where considerable amounts of LNG can be loaded onto ships. In this state, it is easier and less dangerous to transport natural gas, especially when crossing oceans or when traveling to remote areas. LNG is stored in cryogenic tanks at a temperature of minus 162 degrees Celsius and can be easily inserted into the pipeline network and distributed globally.
Stage 3. Transformations. What is the chemical composition of natural gas? Are there different types of gas? And how does the composition of gas affect the price in the market and its use?
The quality and composition of natural gas can vary greatly from one reservoir to another. And the ideal composition of natural gas is usually characterized by a high percentage of methane and a low amount of other heavier hydrocarbons and impurities, such as sulfur and nitrogen, that need to be removed. However, it is important to note that the quality of natural gas can vary even within the same region or site. Technology to treat the gas is often used to tailor the composition of the gas to specific transportation and utilization needs, and also to market demand. For example, the presence of carbon dioxide and water can cause corrosion in the gas lines and affect its energy value or heating value, while nitrogen can reduce combustion efficiency. And these are parts of the gas qualities and go into the definition of what is called the natural gas quality requirements. However, there are some known regions in the world with natural gas deposits considered particularly attractive, precisely because of the high concentration of methane, which is the main and most energetic component of natural gas. And these fields are found in the Caspian Sea basin in Qatar, the Marcellus Formation in the United States. They are also found in Siberia and in Queensland in Australia. Other factors that influence the market price of gas and its use are domestic production, domestic and international demand, transportation infrastructure, energy policies like, for example, gas subsidies or taxes. And also, let's not forget the geopolitical situation at the time.
The first transformation of natural gas is purification. How are impurities such water, nitrogen, and carbon dioxide removed, and why is this process technologically advanced?
The process of removing impurities such as water, nitrogen, and carbon dioxide from natural gas is known as a natural gas treatment process. Natural gas, just like oil, must be purified, must be cleaned to be used, and energy companies and industries want to buy clean gas. And therefore, purification is a crucial step to improve the quality of the gas and make it suitable for transportation, distribution, and final use. There are several reasons why this process is considered technologically advanced. In fact, over the years, advanced technologies for natural gas treatment have been developed and perfected. And these include processes such as absorption, which means the molecules remain on the surface of the material as on activated charcoal, adsorption, refrigeration, membrane, and odors, which allow specific impurities to be removed efficiently. Environmental regulations have pushed so hard on this technological development because gas qualities often require very low levels of impurities to ensure exactly that natural gas is safe for use and meets environmental standards. Technological progress in this process over the years has been remarkable. Innovations have led to more efficient and cost effective solutions as well as reducing the environmental impact of natural gas processing.
What can you tell us about the way this process had advanced during the years? And we know that renewable types of energy often require special facilities to be processed. Is natural gas any different?
Because gas and oil are often found together in reservoirs, their extraction and refining operations have developed together. For example, because gas can contain the same impurities as oil, such as carbon dioxide, sulfur, water, and other compounds that must be removed before the gas can be used and transported, the infrastructure used for refining and processing is very similar to that of oil. And these facilities might be integrated in the same area where the oil is extracted, like in the same refinery or drilling rig, or might be located nearby. Natural gas treatment technologies and processes can be integrated into oil refineries and therefore can enable more efficient use of resources and more effective management of bioproducts. Joint use of infrastructure can lead to operational and economic synergies. For example, transportation infrastructure such as gas and oil pipelines can be shared to reduce overall costs. And finally, in the oil industry, we talk about the multi-phase approach and multi-phase flow, which means that in many fields, oil and gas are present in a multi-phase mixture. And this approach maximizes efficiency and reduces overall operating costs. An example of this type of technology is gas chromatography, which is a technique widely used to separate and analyze the components of a gas mixture. It separates the different compounds in a gas sample based on their chemical properties as they pass through a chromatography column. Detectors and sensors placed at the end of the column identify and quantify the separated components. Experts in this technique can range from analytical chemists, chemical engineers, to analytical instrument technicians and operators, and safety and environmental specialists.
After purification, the gas is transported through pipelines to terminals where the key transformation happens, liquefaction. What are these terminals and how do they work?
Natural gas liquefaction terminals are complex industrial facilities designed to transform natural gas from a gaseous to a liquid state. Let's see how these terminals work. First, the gas is received by a pipeline from a well field after it has been purified, and then it is cooled down, stored, and loaded into tankers or transport vehicles. The largest terminals in Europe are found in Belgium, the Zeebrugge, in the Netherlands, the Gate Terminal, France, the Dunkirk, and in Barcelona in Spain. But also we have to remember the Klaipėda in Lithuania.
Liquefaction is followed by storage in special tanks created to withstand pressures of a few tens of atmospheres. Differently, the tanks made for methane in the gaseous state are capable of withstanding more than 200 to 300 atmospheres. So we see that at this stage, thermal insulation is the key factor, not pressure. Can we explain this concept?
Natural gas liquefaction is a process that involves cooling the gas to extremely low temperatures, usually around minus 162 degrees Celsius, so that it turns into a liquid state. The LNG is then stored in specially designed tanks, and in this process, thermal insulation is critical and often more important than pressure because it prevents overheating of the gas and regasification, and also because it reduces energy loss and makes storage efficient. And finally, because it maintains the quality of the LNG by preventing vaporization, for example. Some of the many companies involved in the supply of gas cooling materials and thermal insulation in the LNG industry are the American Linde Engineering, the French Air Liquide, the French American Technip FMC, and still the French Cryostar. And the choice of supplier often depends on specific project requirements and the charter's preferences. Although there are so many major players in the world in liquefied natural gas production, I will take France as an example here. France's role in the energy transition is represented by the National Energy and Climate Plan, which represents a key strategy through which France seeks to achieve the goals set by the Paris Climate Agreement by aiming to reduce greenhouse gas emissions and aiming to promote more sustainable energy sources. And let's remember that gas is defined as a transitional resource. In addition, France has a long industrial tradition pertinent to the development of technologies used in the production and transport of LNG. As, for example, France has advanced naval skills like those represented in the shipbuilding company Les Chantiers de l'Atlantique, which was founded in the late 19th century. Total Energies is one of the largest energy companies that have the financial resources and expertise to develop the industry. And finally, France has access to well positioned seaports, as on the Atlantic and on the Mediterranean. It also has many LNG regasification and marine transport terminals. And a specific example of French innovation and research on LNG is the famous project Gestion de réseau par l'injection d'hydrogène et gaz vert, conducted in collaboration between ENGIE, the Grenoble Electricity Laboratory, and the CNRS, the National Center for Scientific Research, and finally the Grenoble Alpes University. The project wants to inject hydrogen and LNG into the natural gas grid. It's a great project, in my opinion, because clean or green hydrogen can be injected and transported into the gas grid, and it can therefore use existing infrastructure and be sustainable, economical, and environmentally friendly project.
When the gas is not liquefied for transport through vehicles from land or sea, it is transported via pipelines. What are the advantages and disadvantages of pipelines compared to LNG transportation?
Flavia, there are advantages and disadvantages with both transportation procedures. Transporting gas via pipelines is faster, cheaper, and less emissions once it's built. And it can be more versatile because ducts can transport different types of gas, as we saw earlier. Initial construction costs, however, are very high, more than transport by sea, and pipelines are invasive, crossing land, creating significant disturbances to the ecosystem and communities. Transport by land, but particularly by ship, on the other hand, has no geographical limits and can reach remote regions. And since the liquefied gas can be transported in larger quantities, can also be stored for longer periods.
After a journey that we will explore in more detail in future episodes, we come to the moment of regasification that precedes the feeding into the national grid or other destination grids. This last transformation also takes place through special terminals called regasification facilities or plants. How do they work and what happens to the gas at this point?
Regasification terminals are facilities that convert LNG into natural gas in a gaseous state. And during the process, LNG discharged from tankers is heated through the use of hot water and vaporization to return to its gaseous state. It undergoes eventual pressurization and can undergo analysis and treatment to ensure quality. Once regasified and treated, the gas is ready to be fed into the national grid, as you said, and distributed in the network to become available for domestic, industrial, and commercial use. Again, it is important to mention that the construction and presence of regasification facilities can cause disputes with local communities. For example, in Trieste, in Italy, the project to build a regasification facility has sparked opposition from activists and citizens who were concerned about the impact on the environmental safety and land use. Plus, those against the project say the plant is not compatible with the port of Trieste. And then we can name the protest against the plant as Shannon LNG in Ireland, where locals are more concerned about the effects on the environment, including the risks associated with the presence of dolphins and the possible impact on fisheries. Let's remember that we are talking about gas here, which is a high flammable substance that can explode. The risks in regasification plants are very much there, such as the risk of fire and explosion, gas leaks, and environmental impacts. However, when designed and operated properly, these risks can be mitigated. Facilities are subject to stringent regulations and safety standards with preventive measures and safety devices built in to handle emergencies. For example, leak detection systems, rapid fire extinguishing, and staff are trained to implement and address specific risks. A well known example of an accident is the explosion of the Skikda regasification terminal in Algeria in 2004. The explosion that caused so many casualties and damages seemed it was due to a large gas leak. Safety measures are critical in such cases.
And what plans does the European Union have regarding these infrastructures?
I have already mentioned in previous episodes that the European Union has several initiatives and projects underway aimed at transforming the energy landscape. Natural gas infrastructure detains particular attention. Some of this is because the EU energy strategy, promoted by the European Commission, has the ambitious goal of making the EU a zero emission continent by 2050. And therefore, they push towards cleaner energy sources such as green hydrogen and low impact natural gas. But then we can mention the climate and energy package, which proposes to address the challenges of climate change and promote energy efficiency, including influencing the natural gas sector to reduce greenhouse gas emissions. The European Green Deal is one of the most important and, let's be honest, bold initiatives because it aims to make Europe carbon neutral by 2050. European Green Deal includes a restructuring of energy infrastructure, including the regasification plants, to make them more sustainable. In addition, the green hydrogen strategy and the European network of transmission system operators for gas are projects which show the EU's strong commitment to source diversification and security of energy supply. And also, we have the Recovery and Resilience Facility, again in the EU plan, which is aimed at sustainable investments, including those in the natural gas sector. All these initiatives are part of a collaboration between the European Commission and Member States. I can say that the European Green Deal and the American Green New Deal have much in common. They both have the ambition to address climate crisis through strategies that include investing in renewable energy, improving energy efficiency, creating sustainable jobs, and promoting technical innovation. Both plans pursue climate neutrality goals as they seek to balance greenhouse gas emissions with mitigation actions. And in addition, both take a holistic approach as they consider social and economic aspects as part of the transition to a more sustainable economy. Despite these similarities, of course, the proposals are formulated in distinct political and geographical contexts, and therefore they reflect the specificities of environmental challenges and regional priorities. And one must keep in mind that both strategies do not, however, remain without criticism. Let me give you an example from a famous journalist and activist, Naomi Klein. Her concerns include the risk of assimilation of the Green New Deal into existing capitalistic structures and the danger of greenwashing, which is a term which you might have heard already. By greenwashing, we mean a sometimes subtle communication and marketing strategy adopted by corporations, governments, and institutions in order to build a positive but somehow misleading self image in terms of environmental impact. And therefore, Naomi Klein is also concerned about the possibilities that the participation of big corporations in this making of the Green New Deal will negatively affect the effectiveness of climate policies because these corporations have a lot of power and a lot of influence. Klein argues that given the urgency of the climate crisis and the need for radical transformation, solutions should go beyond the market and address the deep roots of environmental and I would also add social inequalities and injustices. Klein's criticism highlights the call for a more radical and transformative approach to fighting against climate change. The criticisms of the European Green Deal are very much similar to those posed by Naomi Klein to the Green New Deal. And in addition, Europe could be accused of being too naive and Eurocentric in its response to climate change. These criticisms stem from the presumption that other countries will follow the European example, without fully considering different global realities or national priorities. And the approach of Europe could also be considered Eurocentric because of its focus on European environmental challenges without adequate attention to the specific dynamics and needs of other regions, especially developing countries. The view of a natural leading role for Europe could reflect a lack of recognition of the diversity of global perspectives, while proposed solutions could also be perceived as unsustainable or not very applicable in different cultural, economic, and geographic contexts. And finally, this could be criticized as having a lack of consideration of global economic dynamics and the needs of growing developing economies.
Talking about challenges, we have seen how the gas transformation and distribution both required a number of specialized facilities, such as terminals and pipelines. So, my question is, what is the social and environmental impact of these facilities?
I have already mentioned some environmental and social impacts of these facilities, but I can add some more using the research of a British geographer and anthropologist, Andrew Barry. Andrew Barry's analysis often focus on understanding the complex interconnections between energy infrastructure, the environment, and local communities. Barry explores the materiality of energy infrastructure, including pipelines, and how it affects the surrounding environment. His research focuses on the physical transformation of the landscape and on the interactions between technology, the natural environment, and human communities. In addition, Barry examines energy politics and how they reflect and perpetuate power dynamics. He analyzes how the construction and operation of pipelines can be influenced by political decisions and how this decision can have unequal impacts on local communities. One of the key aspects of Barry's analysis concerns public participation in pipeline decisions. The anthropologist explores how local communities are involved in or excluded from decision making processes and how these might influence perceptions of social environmental impacts. Barry also examines the social representation of risk associated with pipelines. He analyzes how environmental and social risks are communicated to local communities and how these representations influence the perceptions and reactions of those affected. Barry takes a political ecology approach to understand the complexity of the relationships between the environment, energy, and society, and to explore how energy decisions affect the distribution of power, access to resources, and local development dynamics. In a 2020 article, Andrew Barry leads anthropological observations together with Evelina Gambino at San Foca in Puglia, Italy, where TAP, which is a part of southern gas corridor from the Caspian Sea to southern Italy, becomes the subject of several disputes. Through this case, Barry and Gambino show that when we study geopolitics, we must consider the political importance of spaces both above and below the flat surface. What does this mean? Indeed, the authors highlight the need to examine the interaction between physical and biological elements influenced by the legal, scientific, and political practices. So the focus here is on a real world challenge: the disruption of construction of the 3,500 kilometer long Southern Gas Corridor. The analysis of the anthropologists explored the tensions not only between countries, companies, and corporations, but also between the operation of above ground pipelines and their construction under the sea and land. There is, in fact, a tension between the widely recognized geopolitics and horizontal economy of oil and gas pipelines, which on one hand are visible on maps as interconnected points, while on the other hand, their underground and underwater formation is increasingly less recognized. For the case of TAP, the vertical impact above the ground on olive groves and the Salento landscape, for example, is more visible, and it's usually used as a topic of disputes, especially used by the NoTAP, which is an activist group. More visible are also the problematic international relations, for example, between Italy and Azerbaijan, which is a fundamental player in the Trans-Anatolian pipeline, of which the TAP is the final segment. However, to explain the geopolitical importance of San Foca, why San Foca and not the port of Brindisi or the larger city of Otranto, it is essential to also consider the underwater construction of the gas pipeline, which includes its proximity to the seagrass meadows of the Adriatic coast, which is always left out of disputes or reports from the authorities. The pipeline, which is more destructive of the marine ecosystems than of the terrestrial one, is strategically made underground, hidden under the landscape to minimize the perceived impact on the surrounding environment and to keep up with we call it the environmental aesthetics of the industry. In fact, while it is easy to map the routes of oil pipelines, their construction always involves interaction with subsoil elements such as rock formations, aquifers, and marine life. Barry and Gambino argue that understanding when and why subsurface materials take on geopolitical significance is critical, especially in the context of debates about the transition to a post carbon economy.
We have reached the end of the episode. We will continue to follow the journey of gas with an episode dedicated to gas tankers. We will talk about the special characteristics of these vessels and the operation necessary for the transport of LNG. Marianna, you conducted anthropological fieldwork on board these ships. Can you give us a hint of our next topic?
In the next episode, I will talk about the other technological segment of gas transport by sea on board LNG ships. I will generally talk about these extraordinary ships and more specifically about two ships very dear to me, Adriano and Traiano Knudsen of a Norwegian shipping company, the Knudsen UAS. I will focus on structures and machines that are fundamental for the transport of natural gas, and I will explain why these are interesting for understanding more deeply the dynamics and social relationships happening at sea, and also to understand how value is redistributed in this industry.
Thank you for listening to The Journey of Gas, a podcast written by Flavia Bazzano and Marianna Betti. This podcast is produced by Flavia Bazzano. The music is composed by Lexin Music.